Okay, we're going to go over number 7 through 12 and maybe beyond if the video is not too long. So if you can see here, I'm using my paper from before, just keeping my work neat, and it's very clear which one's number 1, which one's number 2, 3, 4, 5, and 6. So make sure you keep your work all together, organized, so that it's easy to follow your work. Excuse me. So number 7, it says here, find the indicated angle measure. So make sure that that is what we end up doing in the final, at the end. It says show all work numbered on a separate sheet of paper. So here we are. So number 7. Now you know that these are all interior angles. So blank plus blank plus blank should equal 180. Okay? So then, one of them's 25, one of them's 30, and we'll call the missing angle the question mark x. Okay, so we're trying to figure out what x was, so that when all three angles added together, when they are added together, it comes out to be 180. So that's why x acts like a placeholder to find out what that number was. So these are like terms. 25 plus 30 is 55, plus x equals 180. And then subtract 55 from both sides, so that x equals 125, I believe, is the correct answer, because 180, and you can use your calculator at home. 180 minus 55 should be 125. I'm going to check my answer in the back. And that is correct. And since I found the actual angle measure, it'd be a good idea to write the degrees. Moving on to number 8. Now those of you that like I'll do this one time or two for the variable constant method. So let's say you started off correctly, you add, oops. Okay, and add equals 180. And then you decide to do the variable constant method after you box and circle. Okay, then on this side we've got one variable, no more variables, so then on this side we've got the 180, but then we got the 25, we're bringing it over, it becomes negative 25, bring the positive 30 over, it becomes negative 30. Alright, so nothing to add in this column, so it's just x equals, and then 180, I'm going to use a calculator here. Okay, so let's see, 180, it's 180 minus 55, which actually, if you just do all the work, it comes out to be 125. And since that's the indicated angle measure, that's my answer. Okay? Alright, let's go to number 8. Okay, now I'm going to note here, number 8 is asking me to find the measure of angle A. So in order to do that, I need to find the x using whatever relationship I see here, and then plug it back in. So make sure you're going for that. So this is all interior angles, which means they're going to add up to be 180, all three of them together. And then one of them is going to be x plus 24, one of them is 140, one of them is x plus 24 again, which means that this is an isosceles triangle, but you don't have to know that. Okay, so let's say I box and circle, circle, box, circle, circle, and I combine like terms. These are both ones, so that's 2x, and then I'm going to combine all three of these terms. Alright, so if you add that up, this is 48, so 188 equals 180. Subtract, subtract, 2x equals. Okay, so when you're subtracting, make sure that you do the top minus the bottom. If you end up with a negative, you end up with a negative. Don't like get scared of negatives and all of a sudden change the problem. If the 180 is on top, you got to do 180 minus 188, not the other way around, which ends up being a negative 8. Alright, so then you divide each side by 2. X equals negative 4. Those of you that like the variable constant method, I strongly suggest that you pause the video. Anytime that I begin doing it this way, do it your way, and then check to see if your way matches. So x equals negative 4. However, I'm not done, because it says to find the measure of angle A. Well, where's measure of angle A? That's this right here. So I'm going to, instead of x plus 24, I'm going to substitute in the negative 4. And we're just adding those, so that comes out to be 20 degrees. Now, does that seem like a reasonable answer? To me it does, because 20 is a pretty acute angle. It's pretty small. So if you look over here, this angle here is a pretty acute angle. So 20 degrees seems like a reasonable answer. If I got something like 100 degrees, something should, like kind of alarm should go off in my head, because this is definitely not an obtuse angle. So that means somewhere your math was not correct. So that's just kind of a quick self-check. So let's check the answer. And looks like number 8 says the answer is 20 degrees. Okay. Number 9. Number 9. So number 9, we have, look, we have an exterior angle. As soon as you see that, why don't you write that E to remind yourself, hey, I'm going to be using the exterior angle theorem. Then I have a remote interior, remote interior. All right, and some of you guys know the shortcut, and that's fine. You go for the shortcut. You'll basically, since this is on the outside, you just do 140 minus 78, and you got your answer, okay? And you can just show your work that way. I'm going to go ahead and show the blanks. You have the remote interior, and then exterior. Okay, then, so the exterior, I always want to make sure I put that one in the correct place, because these guys, they can switch it out. You could put 78 here or 78 here. So I'll put 78 here, and then I'll put the X, which represents the question mark there. And then I'm going to subtract 78 from both sides. So X equals, so you take 140 minus 78, which will be 62. And so that means this right here is 62, and that's what X is. And I don't need to plug it in or anything. It's just representing the actual indicated angle measure. So this is going to be my answer. Let's hope for the best. Check our answer in the back. And it is. All right. Moving on to number 10. So flipping the page. Here we go. Number 10. Okay. So number 10, looks like we got an exterior angle, and you'll be like, well, there's two exterior. There's one here, and then there's one here. So which one do I use? The one that has some kind of marking on it, whether it be an X or there's a number. So I'm going to completely ignore this one and use this one, okay? And then you can see here, these remote interior angles are in good relationship to the exterior angle. They're not right next to that one. So that's another good reason that we'll use that one. So that means blank plus blank equals blank. Now for those of you that like the variable constant method, I'm going to do that for you here. And then I'll do the other method. Okay, so I'm going to do both. So those of you that don't know the variable constant method, then you can slightly fast forward or just kind of listen through, because it is an interesting method, and then do the method that we normally do in class. So I see here that the exterior angle is 114, so I'd like to go ahead and get that out of the way. I don't want to mess that up. And then the other one's less likely to make mistakes. You're going to fill it in. So this looks like a minus to me. I hope that's a minus. Alright, so if it's not, then we'll go back and change it to a plus. 3x minus 7, and then 7x minus 3. Alright, and I'm going to do the box and circle. That's what everyone needs to do. And then I'll put the variables here and the constants here. Make sure you have it lined up with the equals. Okay, those of you that don't know this method, I'll show you the other method in just after I do this one. So you put the variable terms here. So I have a 3x here. I have a positive 7x here. And then no more terms, or no more variable terms. So now over here I have a 114. But these other constants are on the other side of the equal, so a negative 7 comes over, it becomes positive 7. Alright, and then negative 3 comes over and becomes positive 3. Then we add. These add to become 10x. These add to become, that's 10, so that's 124. Something doesn't seem right about this, but maybe. Let me double check. No, let me double check. So number 10. That kind of looks like it was supposed to be a plus, but I'm going to check the answer real quick to see if it's going to have a decimal. I don't think so. No. Okay, so let's say that this was supposed to be a just give me 1 second. What if this was supposed to be a plus? Then it would come over here to be a negative. So it'd be a -4. I think this is that's what's supposed to be. So yeah, I kind of suspected, but sorry for the copy, guys. This should be a plus. That should be a plus. Okay. So over here we've got, I apologize for the confusion, and I thank you for just following along with me. So this is going to be 110. Okay. So when you divide each side by 10, the x equals 11. Okay, so, but I don't know if we're done. It says to find the measure of angle DEF. So let's take that 11, and we're going to substitute it in for the x wherever angle DEF is. So let's see, DEF. So they're talking about this angle. And at that angle, we see a 7x minus 3. So instead of 7x minus 3, we're going to substitute in the x, which is 11, and then minus 3. So 7 times 11 is 77, subtract 3, and that's 74 degrees. Now let's see if that's a reasonable answer. Yeah, that's definitely an acute angle, but not like super acute. So that seems like a reasonable answer to me. Let's see. Number 10. All right. Phew. There we go. I've run out of space, so I'm going to grab another sheet of paper and do number 11. Okay, I see all interior angles here, and the pluses are obvious. Okay, good. So that means we're going to do, we're going to add them up to be 180. So I'm going to make 3 blanks. And then I'm going to put, in one of the blanks, I'll put 80. Another one is 60 plus x. I'm on the staple here. And then x plus 60. Oh, looks like another isosceles triangle. Again, you don't have to know that, but interesting observation. Alright, so, oh, and I didn't do it for the other method, did I? Or, let's see. Oh, I just stuck with the variable constant method on number 10, but I hope that you guys know how to combine like terms on one side and then subtract them. So for the sake of the variable constant group, I'm going to go ahead and say those that like the other method, try it your way and see if it works out, okay? Alright, number 11. Okay, I'm going to do the usual way that we do it, which is combine like terms. So here, combine these terms, and then combine these terms. Alright, so 1x plus 1x is, let me bring this up a little bit, 2x. Now 80 plus 60 is 140 plus 60 is 200. So 180 minus 200 looks like we're going to get a negative. If you do it in your calculator, you should get a negative 20. Divide by 2, divide by 2, x equals negative 10. But did I actually answer the question? No. Oop, I forgot to write the answer for here. Number 10 should have been 74 degrees. And number 11, it says to find the measure of angle B. So angle B is here, and they only need to use one letter because there weren't other angles here at that same, using that same vertex B. So that's why they only use one letter here. Whereas here, if you look at DEF, it's that E is sharing another angle here. So if we just say angle E, we don't know if you're referring to this angle or this angle. So 3 letters were used. Okay, so let's look at number 11. We're finding measure of angle B, so we got to substitute in the negative 10. So instead of x plus 60, we're going to write negative 10 plus 60. Okay, since they're different signs, you should subtract out the 0 pairs, and you keep the higher positive. So it's going to be a 50. 50 degrees is an acute angle. Does that seem reasonable as this angle here? Yeah, because that looks like it's about a little over half of a 45. I mean, it looks a little bit more than half of a 90 degrees. So 45, a little bit higher than that, if that makes sense. If it doesn't, don't worry about it. Okay, so the answer here is 50 degrees. Drum roll, please. Hope for the best. It is, yes. Okay, number 12. Number 12, what kind of angle situation do we got going on here? We got an exterior. Let's use it. Okay. All right, so this should look familiar. And I think this looks a little bit confusing for some students because they're like, okay, these are so close to the angles, I don't know which angle. So just know that 11x minus 3 is referring to this angle. 13x minus 13 is referring to the exterior angle, okay? So these are remote interiors, all right? And so let's try it. So number 12, we got the exterior angle situation going on. Okay, so we have the exterior angle. I always like to take care of that first. So that's over here, 13x minus 13. Then I'm less likely to mix it up and put it in here and be all wrong. So we got a 30 degree. Let's see if I can scoot this over, the plus, to give some room to the longer expression. So 11x minus 3. So we have, alright, so like terms. Now again, if you prefer the variable constant method, pause it now and then try it your way. For those that, I will do the variable constant method after I do this one. I'm going to remind myself to do it over here. Okay. So first I'm going to do the other method, which is we'll combine like terms, and that's a 27. So 11x plus 27, or you can write 27 first. And then nothing's happening here, so I'm just rewriting it. And then I'm going to rebox and circle. Okay, so then we have variables on both sides, so I'm going to remove the smaller variable. And I subtracted because it was positive to begin with, the 11x. And then we have 13x minus 11x, that's 2x. And then subtract 13, or bring down the 13, I mean. And then add 13, looks like a B. Eliminates. So then these add, and that becomes 40 equals 2x. Divide by 2, divide by 2. X equals 20. Okay, but did I answer the question? Let's go over here. No. I need to plug it in for the measure of angle AFG. So I'll do that in a second after I do the variable constant method. Okay, so variable constant method, still you got to do blank plus blank equals blank, right? I'm going to make this blank shorter because it's going to be the 30. So here we go, and then we have 30 here from, oh, and let's put the exterior angle in first, which was 13x minus 13, and then we'll put the other terms in their blanks. Okay, so alright, now this is where I'm going to use the variable constant method. So circle, box, circle, box, circle. Okay, so we have 30 plus a negative 3, that's a 27. Oh, no. Look at me. Sorry. We got to do variable constant. Okay, here we go. So on this side, we got 11x as a variable. No more variables here, but on this side, we got a 13x. But you're bringing it over from the right side to the left side, so you got to change its sign. So that one's done. On this side, we got a negative 13, but then we're going to bring the negative 3 over, make it positive. Bring the 30 over, make it negative. So we got a mix of positives and negatives here, and that's fine. Just add them all up. So 11 plus a negative 13 is a negative 2x. Okay? And then a negative 13 plus a negative 30, that's a negative 43. Then add a 3, that's going to be negative 40. Now be careful here. When you're dividing, divide by the same sign so that they become a positive 1. Okay? So then this becomes x equals 20, which is what we got here. So we're good. Now we're going to take these and we're going to substitute it in to find the measure of angle AFG. So measure of angle AFG, where is that? Let's see. It is AFG. So it's referring to this angle, which is the 13x minus 13. So instead of 13x minus 13, we're going to write 13 times 20 minus 13 and multiply those. Okay, so that's, something doesn't seem right. That's too big. So did I miss a plus somewhere? I don't think so. Okay, so something doesn't seem right. AFG. No, this is going to be too big, so something is not right. Huh. Okay, give me a second here, sorry. Let's see. Did I read it off wrongly? No. So is this one of these a plus again? I really hope not. Okay, give me 1 second. Alright, let me check something real quick. Give me like 5 seconds. Well, maybe a minute. Oh my goodness. Okay. Oh my goodness. Okay, so the copy didn't come out as plus, so these are supposed to be pluses. You know what? Gonna have to start over. Hey, it happens. Life happens. Okay, so if those were minuses, we actually did it right. Okay, if these were minuses, we actually did it right. But these were not minuses, so starting over. And lesson learned. I mean, I don't know why the copies, somehow it doesn't show up as a plus. I am sincerely sorry for that, but we're gonna have to start over. Okay, so alright, I guess we could go back and just change that, but it's just a big mess, so I'm just gonna go ahead and start over. So we have a blank plus blank equals blank, and then we've got 11x plus 3 and then 30. Sorry, I'm a little bit like, what am I doing now? Okay, 13x plus 13. I'll probably put yeah, we'll see. Okay, so we'll go ahead and do the original method, and then we'll do the variable constant method, okay? Combine like terms. So now we're adding these numbers, not subtracting. So you got 11x plus 33 equals 13x plus 13, not subtracting 13. Okay, so box and circle, and subtract the smaller variable. Always take care of the variables first, if at all possible. It becomes less confusing that way. And then it's 2x plus 13, and then subtract 13, subtract 13. 2x equals 20, divide, x equals 10. Okay, that's what it's supposed to be, not negative 20. Well, let's see if the variable constant method also shows us that. So I'm going to recopy it. 11x plus 30 equals 13x plus 13. And box and circle, box and circle. Okay. So we get 11x plus 33 equals 13x plus 13. Oh. What am I doing? Sorry guys, variable constant people. variable, constant. Okay. So on this side we've got 11x, and then the 13x is going to come over and become negative 13x. And then 13 is already here, stays positive. 30 comes over, becomes negative. 3 comes over, becomes negative 3. Add them all up, add them all up. This becomes negative 2x equals, and then this one comes out to be a negative 20. Then divide, x equals positive 10. Okay, now we're ready to substitute into the 13x plus 13, which is going to be 13 times 10. Now that makes more sense. Plus 13. So if we have these, you multiply before you add, so 130 plus 13 is 143 degrees. Is that a reasonable answer? Yes, that's your obtuse angle, and it looks pretty obtuse, so 143 is a reasonable answer. Let's go to the back, and yay, the answer is 143. Okay, so now let's go to 13. Well, I'm going to pause. No, I guess I could keep on going. All right, so let's go to number 13. So number 13, you don't have to show any work. You just have to write the angle pair relationship. So name the angle pair relationship. Your choices are vertical angles, linear pair, alternate interior, alternate exterior, same side interior, same side exterior, corresponding. Let's count. 1, 2, 3, 4, 5, 6, 7. There's a total of 7 angles that you need to know. Okay? So remember how we categorized it last time? We said, okay, first start with the SSI, SSE, LP, and those are the ones that the two together add up to be 180, and then the rest of them are equal, like alternate interior, alternate exterior, corresponding, and vertical, and that takes care of the rest. So 1, 2, 3, 4, 5, 6, 7, 7 angles. Alright, so let's look at this. Loop here, loop here. Hey, they're adjacent to each other, and you don't need parallel lines for this. They are linear pair. You can see it makes half a moon, as Ms. Hastings says, and it's a straight angle. So on this side, it makes a line, therefore the name linear pair. And as a review, this is the situation. You don't have to write this, but maybe it'll help you to just review. This is the situation where the two angles add up to be 180. Okay? And you'll need to know that. We're going to practice that a lot on Monday. Okay, now here, number 14, some students want to look at that as vertical, but they're not, because if you put a loop here and a loop here, they're not connected, creating a bow tie. So that's not a vertical angle. And notice you have parallel lines and cut by transversals, so it's going to be one of those other angle pair relationships. So if you look at this, this is in the exterior, okay, and this is in the exterior. But they're not on the same side of the street or same side of the transversal. You had to cross over the street to get to that. So this is alternate exterior. Now, as a review, what do we know about alternate exterior? They're not SSI, they're not SSE or LP. They're going to be equal to each other. So if we had an equation, we would set them up equal. And another clue is that if one's acute and the other's acute, they're equal to each other. Alright, these are obtuse and acute. This is acute and that's obtuse. They're going to add up to be 180. Number 15. Okay, this looks kind of strange because it looks like you've got like angles outside, but if you ignore these, okay, if you ignore these and just think of it as two, let me make this, two lines. Aye. Like this. Okay? Or if it helps you, just redraw it again to the side. I'll make a smaller version of it. And I see that A's here, and I see that B's here. It makes a bow tie, guys. So what is it? It's vertical. And vertical angles are always equal to each other. Okay? See? Right here. Number 16. Alright, we've got parallel lines, and we've got an interior angle. They're not at the same line, so it's not vertical or linear pair. But if you look at these, they are in the interior, so you're going to use one of the interior names, either this one or this one. So the question is, are they same side interior or are they alternate interior? Well, they're on the same side of the transversal, so these are same side interior. Number 17. Alright, so number 17, these angles right here. So, oh, by the way, these are obtuse and acute, and same side SSI, SSE, LP, they add up to be, these two pairs, the pair adds up to be 180. Okay, over here, we've got an angle right across from the other and making a bow tie, so this is vertical, which means they equal each other. If you want to confirm that, look over here. It's under the equal category. Alright, over here we've got an A and a B. They're not in the same location, so it can't be vertical or linear pair. And when the parallel lines are sideways like that, just imagine that this here is your interior. So A is in the interior, B is in the exterior. They're on the same side on different parallel lines. They're actually in corresponding locations, so corresponding angles. Okay? Alright, number 19. Number 19, we have, they're between the parallel lines, so this is interior, and this is interior, but they're not, so it's going to be one of the interior, what's it called? Interior angles. Is it going to be same side interior or alternate interior? So alternate interior, because they're not on the same side, you have to cross over the transversal to get to the other one. So alternate interior. Okay, number 20. Number 20, you got parallel lines, and you have M and N. They're not near each other. They're not connected, okay, by the same vertex. So they are not going to be vertical or linear pair. So you have to think about them in terms of interior, exterior. Well, here's the parallel lines. There's nothing in between them, so these angles have to be exterior. Here's your transversal. Are they on the same side of the transversal, or did you have to cross over the transversal to get to the other one? They're actually on the same side. So same side, exterior. Okay? Number 21, these angles are next to each other. They're not making a bow tie. These are linear pair. Now, I can go back real quick and just review, corresponding, those are equal to each other, by the way, obtuse, obtuse, they're equal. Number 19, they're also equal to each other, so alternate interior. Notice they're both obtuse. Same side exterior, SSE, so that's going to be adding up to be 180 because, and also you can look, one's obtuse and one's acute. They add up to be 180. And then number 21, linear pairs, one's acute, one's obtuse. They add up to be 180. Okay? Alright, almost there. Okay, I think I'm going to pause the video here. I'll make another video for number 22 and the rest.